Okay, this is an introduction to trigonometry. You have these notes here, and I'm just going to help you a little bit with them. It starts off and they say trigonometry can be found in many fields like navigation and engineering and architecture, and that's really true. But this trigonometry is even more special than that. Trigonometry, it's used for the language of everything that goes in circles or cycles. And one thing that does it so fundamental in science is waves. So it's the mathematics of everything that that's wave-like. And that has just thousands of applications in science and technology. It's right the fabric of nature itself. So trigonometry is the language of it. We don't figure that out in high school too much. Well, we start to maybe, but it's really quite an exciting thing. They say that we use these words, theta, beta, alpha, and phi, often to symbolize angles. In grade 8, we learned this thing about Pythagoras. If you have a right-angled triangle, if you make squares out of the sides of the triangles, next to the right angle, it equals the square of the hypotenuse. And that's the theorem of Pythagoras. We're going to use that again. We need to start off with trigonometry. What's really important is a right angle triangle and naming the sides. Now, you guys probably know that the side opposite the right angle is called the hypotenuse in a right triangle. But if you're talking about this angle B down here, this side right CB is called adjacent. And that word adjacent, it's really important to be able to name the sides. This side here, AC, is opposite to angle B. Now, if I move the angle, I look at the angle up A, adjacent and opposite, they switch. This side AC now is adjacent for angle A, and CB, that used to be adjacent, is opposite to angle A, but the hypotenuse stays the same. Now, what we do in trigonometry is we make fractions out of those sides, and we call them trigonometric ratios. So the sine of an angle is what's opposite the angle over the hypotenuse of the triangle. The cosine is the adjacent over the hypotenuse, and the tangent of the angle is opposite over adjacent. If you make those fractions, those are the three trig ratios. Now, the example they give, they start off with a right triangle. They say it's 5 on one side, 12 on the other. And the first thing they want you to do is to determine DF. And then they want you to find all the sine, cosine, and tangent of this angle theta, and then sine, cosine, and tangent of this angle beta. Well, let's just see how they do it. Well, to get the DF, all they do is go 5 squared plus 12 squared. That's 169. They take the square root, and they get the DF is 13. Well, now they know the hypotenuse, so they just go up to these ratios. The sine of the angle is, let's go to theta. 5 is opposite to theta, so it's 5 over, and now we know 13. The cosine of theta is 12 over 13. It's adjacent to theta, 12 over 13. And the tangent of theta is opposite 5 over 12, which is adjacent to theta. So there's all of theta's trigonometric ratios. But for beta, things change, because for beta, what was opposite is now adjacent. So it's 5 over 13 is the cosine of beta, and the sine of beta is 12 over 13, opposite over that. And the tangent of beta is opposite over adjacent is 12 over 5, so it's turned upside down from theta. Well, you're going to have to do some questions like that and do some thinking about these trigonometric ratios. We're just going to start off. That's our introduction. Anyways, trigonometry is really cool. It's a type of mathematics that can be really exciting if you get interested in physics and other stuff later on. Okay.